In this video, I'm going to go through our notes for lesson 1.5. I'm going to go through this kind of quickly. If you feel like you need to pause at any point, I'm kind of assuming that you will, to either write some of this down or try some of the problems yourself and then unpause and kind of see the solutions. 1.5, the only thing that we're changing is there are now going to be variables on both sides of our equation. And we handle that almost exactly like we have in the past. What I always like to do first is get all of the variables to one side of the equation, and then get all of the numbers to the other side. So this might make more sense if we just look at an example. Okay, so if this is our starting equation here, notice there's variables on both sides, which is not what we're used to. We're used to just having like the x or whatever our variable is on one side of the equation and then trying to get that all by itself, right? Our goal is usually to get x equals some number. When we have variables on both sides, we need to get all of the variables to one side and then all of the numbers to the other. And then from there, it's going to be just like everything we've done up to this point. So we can add and subtract these just like we can numbers. Okay, so what I've done in this first step is just subtracted 2x from both sides, right? And if I have 2x and I subtract 2x, that goes away, right? That just turns into 0. That's why we're left with just 5 on this side of the equation. When I subtract 2x from the left side, I have 3x minus 2x, and I end up with just 1x. Okay, so everything else stayed the same. The 2 just stays, the 5 stays. So we just deal with the variables first and then the numbers. Okay, you could deal with the numbers first. It'll work out fine. I just find it easier to do it this way. After we've done that, we end up with just our basic one-step equation, x plus 2. So to get x all by itself, we're going to do the opposite. We're going to subtract 2 from both sides, and we find that x equals 3. So again, really similar, we're just adding one little step. We still need to combine like terms when we can. We still want to look for the opportunity to distribute. We're just adding one little thing. When we get solutions, however, we may notice some differences. Okay, so this is the solution we're used to, like just x equals a number. But when we have variables on both sides, it's not always going to end up that way. That is option number 1, right? This is what we're used to. We end up with one solution. And when that's the case, it'll look just like it has up to this point. The variable equals some number. Option 2 is we may end up with no solutions at all. And we'll see an example of that in a few minutes. But what that looks like is we go through the normal process of solving. And then all of the variables are going to end up going away, and we will end up with a false statement. So for example, if I go through my solving process, all the variables end up canceling out, and I end up with something like this, 0 equals 3, that is not a true statement. That tells me that there are actually no solutions to the equation. Option 3, I could have infinitely many solutions. And again, in this case, the variables will cancel each other out, but I'll end up with a true statement, such as 3 equals 3 or 0 equals 0. And those are the 3 options that we have. So let's take a look at a couple examples. So number 1, we've got variables on both sides. Okay, remember our goal is to first get the variables to one side and all the numbers to the other. Since this side has a number 10 and then that variable 4x here, and then the other side just has the negative 9x, what we would want to do is get rid of this 4x from the left side of the equation, because when we do, we'll just be left with 10 on the left, and all of our variable terms will be on the right. So let's do that. I have minus 4x, so to make that go away, I'm going to add 4x. If I do it to one side of the equation, I have to do it to the other side of the equation. If you're somebody who likes to draw that line, feel free to do that. So on the left side, we're just have 10 equals, and now I had negative 9x plus 4x. So remember, these are like terms. I can combine them. I just think of it as like I have negative 9 of something, and then I add 4 to it. And we just end up with negative 5x. Final step. Again, we're back to just a one-step equation now. I've got negative 5x, which means negative 5 times x. All right, so to undo that, we're going to divide by negative 5, divide by negative 5, and 10 divided by negative 5 is negative 2 equals x. And then we normally write that as x equals negative 2. To check our solution, remember we just plug that x value back into the equation. So 10 minus, actually, let me do it this way. 10 minus 4 times negative 2 equals negative 9 times negative 2. So when we do this multiplication here, okay, I'm going to just leave the sign as it is, and I'm going to do the 4 times negative 2. So I've got 10 minus 4 times negative 2 is a negative 8 equals negative 9 times negative 2 is a positive 18. When we subtract a negative, remember that's the same as adding a positive. So on the left we would have 18 equals 18. This is a true statement. It works. Okay? This was just checking. Remember, we had plugged the variable back in, so this isn't that case where we got rid of the variable. That was just us checking our work. Number 2, we need to do some distribution first because we can. Remember this, the number sitting right outside the parentheses is what tells us that we need to do that distribution. So I'm going to multiply through here, and I'm going to do the same thing on the other side. Okay. So on the left, 3 times 3x is 9x, minus 3 times 4 is 12, equals 1/4 times 32. That's the same as 32 divided by 4. If you were going to punch this into your calculator, you would want to do it like this: 1/4 times 32. Okay. When you do that, you should get 8. So this is 8x plus 6. Okay, so we've done our distribution. We can't combine any like terms, right? I only have one x term on each side, and I only have one number on each side. So that means we need to get all our numbers to one side and all of our variables to the other. If you think ahead a little bit about your possibilities, you'll find a way that usually works a little bit better. For example, if I were to subtract 9x from both sides, my variables would go away on the left. On the right, though, if I subtract 9x, I would end up with a negative x value. And that's not usually the greatest thing. It causes us to have to do a little bit more work. So I always try to think ahead and think about which one of these should I subtract so that I end up with a positive x value. And that's going to be the 8x. Okay? Because now that variable term is going to go away on the right. I'll have x minus 12 equals 6. And again, we're just back to a one-step equation. Add 12 to both sides, and x equals 18. And again, we could check our work by plugging that back in. That is quite a long solution, but if you plug that in, plug that x equals 18 in for each of the x values, and then simplify, we should get that true statement. All right, moving on. A little bit shorter here, but the same idea. I need to distribute and solve. 3 times 5x is 15x. 3 times 2 is 6 equals 15. X. Okay, we want to get all of our variables to one side. Okay, so my only numbers are on this side, so let's let's subtract 15x here on the left, minus 15x. But look what happens when we do. I end up with 6 equals, and on the right now, I had 15x minus 15x. This is 0. So this is that situation where all of our variables went away, and I'm left with an untrue statement. This tells me that this equation has no solutions. Next, we got some fractions. Everybody loves fractions. Again, what I'm noticing when I look at this is I've got a variable term over here, and on the right I've got a variable term and a term that is just numbers. Okay, so I'm going to try to make this one go away so that I'll get all my variables over here and all my numbers over here. Okay, we're always thinking about what's happening on both sides of the equal sign. So on the right I've got a negative n over 6, so I'm going to add n over 6. And so we think of that as like 1n over 6. So if I have 1n over 6 plus 1n over 6, that's 2n over 6 equals 1 over 2. And so we can go about this a couple different ways when we have the fraction. You might simplify that fraction on the left side first. What I like to do is multiply by the reciprocal. So if I've got my fraction is 2 over 6, if I multiply by 6 over 2, that's going to make that fraction go away and leave me with just n. Because when I multiply across, 6 times 2 is 12, 2 times 6 is 12, 12 over 12 is just 1. So n equals, and now I'm going to multiply straight across here as well, because I've got fractions. 6 over 2 times 2 is 4. And that one we should reduce, right? 6 over 4 is the same as 3 over 2. So this is that case where I've got one solution again, right? N equals 3 over 2, or 1.5. All means the same thing. Clean that up a little bit. Final example here. Again, we have distribution. So negative 2 times 4y, negative 2 times 1. I end up with negative 8y minus 2 equals negative 8y minus 2. Notice we have the exact same thing on both sides of the equation, and this is your indicator. You're going to see how this ends up, but this is kind of your clue right here. When I start doing things to both sides, when I add 8y, what happens? They go away on both sides. So I end up with negative 2 equals negative 2. My variables went away, and I'm left with a true statement. I could add 2 to both sides again, but it's unnecessary. I would just end up with 0 equals 0. So this is that case where I have infinitely many solutions. Okay. Or if you want to write it out, that's fine. Infinite solutions. Okay. And what that means is that no matter what number I plug in for y, this equation is always going to be true. Okay, so if I let y equal 1, then the equation will be true. If I let it equal 2, it'll be true. Any number I plug in for y will be true. That's why we have infinitely many solutions. Okay, time for you to try a couple on your own. This is a place for you to kind of look at the examples above, try to do some of this yourself, and see how it goes. So in this first one down here, we want to get all our x values to one side. So I'm going to subtract 3x. Okay, because my only number values are on the right side. So this gives me negative 5x equals 10. Down to a one-step equation here, divide by negative 5. And you get x equals negative 2. Single solution. Over here, we're going to distribute. Okay. 0.5 times 6h is going to give us 3h. Multiplying by 0.5 is the same as dividing by 2. Minus 2 equals negative 5h plus 1. Let's get all of our variables to one side. I'm noticing if I add 5h to both sides, that'll keep my variable terms positive and get them all to the left. So that's what I'm going to do first. So 3h plus 5h is 8h. Everything else stays exactly the same. Now I've got to get all my numbers to the other side. All right, so let's add 2. And we end up with 8h equals 3. Final step, 8h means h times h, so I need to undo that by dividing. And we do end up with a fraction, which is okay. H equals 3 over 8. And if you punch that into your calculator to get a decimal number, you should end up with, I believe it's 0.375. Okay, there we go.